This 800 horsepower monster belongs to JTEKT sponsored Casey Curry, who runs JTEKT bearings in his rear axle. There's no clearer testament of a component's durability than to survive this kind of abuse.
I'm Courtney with JTEKT, and today we're going to talk about tapered roller bearings. So what is a tapered roller bearing? Well, when we look at a tapered roller bearing, like the other type of bearings, rolling element bearings, they're going to have four components, an outer ring, an inner ring, rollers, and a cage. But it's a little different with tapered roller bearings. We call this a cup, and we don't call this an inner ring, we call it a cone assembly. So a cone assembly includes this race, this inner ring race, as well as the rollers and the cage. And then this outer race, again, we call a cup. So we call it a cup and a cone, and the cup goes over the cone. Metric product is going to be made out of the 52-100 material. So this cup and cone race area, just the part where the rollers are riding, are going to be made out of 52-100. The rolling elements, of course, are going to be made out of 52-100. The cage is typically going to be a stamped steel, so just a low carbon steel. And as the name suggests, tapered rollers. So the rollers have a taper on them. Now, for inch product, when we talk about the inch product, so it's going to have an inch bore versus a metric, we don't make it out of 52-100, we make it out of a material called 8620. The 8620 is a little bit different. 8620 is a lower carbon steel or a low carbon steel. We introduce carbon during the heat treat process, and that makes it hard. So that's what gives it its hardness. But the middle of the bearing, so the core, is still going to be soft. And so why is it soft? It's better for taking high impact loads. So if you hit it really hard with a 52-100 product, if you hit it hard enough, you'll fracture the bearing. So it'll actually crack. It'll physically come apart. With 8620, if you hit it really, really hard, it'll dent it, but it won't necessarily fracture all the way through. Now, will the bearing be damaged by hitting it that hard? Yes. So you're still going to get a premature failure, but you're not going to get a failure right away. So the bearing still might be able to operate, but it's going to fail prematurely. So what are the size ranges for tapered roller bearings? Anywhere from 15 millimeter bore, actually pretty common, but we can actually go smaller than 15 millimeter, but 15 millimeters is kind of the catalog size, all the way up to 3,000 millimeters or bigger. So we're talking about a bearing that's, again, from about a ½ inch bore all the way up to 120 or 10-foot bore. So where's a bearing like that used? You're going to find something like that in a steel mill, or you're going to see it in a tunnel bore type equipment. So those big machines that actually make a hole big enough to put a tunnel in for a car to drive through, those are going to have those huge, large tapers. Now, what's a tapered roller bearing design? What kind of load is it designed to take? Very high radial and very high axial loads. Now, when we talk about the difference between the metric and the inch product, the metric product is bought as an assembly, meaning that this cup and cone come together in the box. We have one part number for this complete assembly. Now, the inch product is different. The inch product, there's a separate part number for the cup and a separate part number for the cone. Now, you could still buy them as an assembly and get them in the box together, but a lot of times you'll buy just the cup and the cone separately. Why is the metric you can only buy as an assembly, and the inch product you can buy as a separate cup and cone? This product was invented here in the United States, and what they found was they wanted to have a whole bunch of different types of cones, different modifications to that cone that they could use for the same cup. So they might want to make this corner radius here different, or they might want to make the bore slightly different, but they wanted to keep the same roller and cage, so they wanted to keep all the same size rollers so that they could use the same cup. So you could have 5 or 6 different cones that fit with the same cup. And so they had to create different part numbers for each of these individual components. Now, these are also available in high precision. So you can get high precision product, again, using CNC type equipment. Can't go as fast as your ball product, obviously, because it's a roller type product. Can't get seals or shields. Why? Well, because it comes apart. So there's no way to attach a seal and have it contact that inner ring consistently. So you're not going to be able to get this with snap rings either. And that's the other thing, these parts come apart. You know, when we talked about a ball bearing or a cylindrical, you can see that these parts all come together. They don't fall apart if you shake them. This obviously, they come apart, so there's two parts. Now, what else about a tapered roller bearing? The angle of these rollers. So these rollers are at a certain angle. Well, we can get these at different angles. So the steeper the angle, so the more that those rollers are going like this, obviously the more thrust load it can take. The flatter the rollers, where they almost look like cylindrical rollers, the more radial load it's going to take. So you can vary the angle of those rollers depending on what your design requires. So depending on the application, if it requires a lot of axial load, you're going to have steeper angle. If it requires more radial load, it's going to be a flatter angle. And again, not a unitized assembly, so you got to find a way to hold those cup and cone together, right? So when we install a ball bearing on a shaft, press it onto the shaft, and it stays in that position. Well, obviously we can press the cone onto the shaft, right? But we got to find somehow of making sure that that cup engages those rollers. So, like angular contact ball bearings, these tapered roller bearings are going to be bought in pairs. So we're going to buy 2 of these, typically, usually the same size. Sometimes they can be different sizes. But just like angular contacts, we're going to probably get 2 of these and they're going to be opposed to each other. So these only can be assembled in one direction, right? So these are not symmetrical when it comes to installation. You can only install these depending on which way that thrust load is going. So a lot of times we'll get the identical part and we'll flip it around the opposite way. And that way we can take a thrust load or an axial load in either direction. And we'll kind of force these together so we ensure that that cup is engaging all of those rollers. So that we ensure that we're pushing that race into the rollers. And we call that a preload. Why use a tapered roller bearing? It's the best all-around bearing that you can buy. In regards to that, it can carry a high radial and high axial load. So no other bearing can do that. So if you had to pick only one bearing that you could only use for everything, the tapered roller bearing would probably be your choice because of its ability to take any kind of load. The other part is it's high volume, so there's a wide variety of product. The only problem with the tapered roller bearing is the assembly part. You have to figure out how to push that cup into that cone. Now again, the small volume product, so tapered roller bearings, this is about as big as you can get in regards to the high volume parts. So anything about this big or smaller, we consider that high volume, those are going to be low cost because there's tons of them made. Wide range of sizes. So not only do we have inch, but then we have metric sizes as well. The tapered roller bearing is the second most popular rolling element bearing next to deep groove ball bearings. A lot of design flexibility because of its product offering. We have tons and tons of inch product and tons of metric product. So there's multiple series, which means we have multiple roller sizes for the same bore size, multiple angles that we can choose from. So again, just like an angular contact ball bearing, when these are mounted correctly and they're preloaded, that makes the shaft very stiff. So it can't do this at all. So if you can do that, if you can install it properly and accurately, then you can control the rigidity of that shaft and actually control the accuracy as well. Where are these used? Tapered roller bearings, again, the smaller bore stuff, heavy duty truck axles, trailer hubs, train hubs. They were invented because there was a manufacturer of wheels, of wagons, and the problem with his wagons were they couldn't go around turns very fast because there was thrust load when you go around a turn. And in those wagon designs, you basically had a steel bushing that was inside the wheel and then a steel bushing that was on the axle itself. So that was going to take a pure radial load, but it couldn't take any type of axial load or thrust load. So this carriage manufacturer came up with the tapered roller bearing design. When tapered roller bearings were first designed, they went into cars. So you didn't have ball bearings in those wheels, you had tapered roller bearings. When they switched from tapered roller bearings to ball bearings was because of the oil embargoes in the early 70s. And so the roller bearings generate more friction than ball bearings, and they didn't need all that load capacity that you get from the tapered roller bearing. So they redesigned those to ball bearings because they take less friction. But before that, all your cars, all your wheel axle bearings were tapered roller bearings. Today, all of your trucks, typically will have tapered roller bearing. Where else are they used? The larger tapers are used in metal making mills, so like steel mills, aluminum mills, and then obviously in wind turbines, back in the gearbox, which they're still very large tapered roller bearings. So equipment like tractors, earth moving equipment, commercial lawnmowers, those will all have tapered roller bearings in it. Aircraft landing gear is a great example. Precision tapers, again, are used in CNC machines. So tapers are pretty much everywhere. So in summary, tapered roller bearings are a good low-cost solution. If you had to pick one type of bearing for everything, the tapered roller bearing would probably be your choice. We hope you enjoyed this brief course on tapered roller bearings. We've covered key components and why they are the best bearing choice for handling both heavy radial and axial loads. Stay tuned for more bearing training from JTEKT, formerly known as Koyo.